Hi, welcome to the first of our engineering weeks. What we're going to be doing this week is applying the scientific concepts that you developed from week 2, so the things we learned about heat transfer. So if you think back to conduction, convection, radiation, and you are going to be using those concepts to save the penguins. Your penguin is going to actually be an ice cube to represent the penguin, so you're going to think about how you're going to have to protect your penguin from heat in the form of conduction, radiation, and convection. If you click on the YouTube video, so I'll post these PowerPoint slides so you can go through at your own leisure, obviously, and you can actually do some clicking. You'll hear the author of the curriculum introducing the design context and give you a better sense as to why we're doing what we're doing. It's not worth me trying to paraphrase what she did a lot better than I would do. You're going to want to prepare your cooker, which is where you'll be testing the habitat that you build to protect your penguins. So this is using the materials I asked you to get from week 2. You'll see a picture there of your habitat. So this is the plastic box that I asked you to get. You're going to be painting the bottom of the box black. You're going to be lining the sides with aluminum foil. And then you'll have your heat lamps or desk lamps, whatever you are able to get. Preferably 100-watt bulbs, but but don't melt anything. That will be then adding that heat into the cooker, and your penguins will be going right down inside that box. So you'll want to prepare that ahead of time. You don't need to have the lamps on until you're ready to use it. So the materials that you have available to build your penguin habitat are also the ones that I asked you to collect during week 2, some of which you've probably done a little bit of work with as you learned about heat transfer. So you'll see a list there. I won't read them all off. There's also a picture, so you've got your baking cups, your felt, your craft sticks, all of those kinds of things. You're also going to have a budget, which would be realistic for engineers. Anything engineers do is expensive, but they can't spend an infinite amount of money, so you will have a budget for the materials that you'll be able to use to help protect your penguin here. So as you start to think about that, and I will have the budget on the PowerPoint, so don't worry about that for right now. But you're going to want to think really carefully about what materials you're going to use, given that you have a budget. So what you should first do is do a little bit of exploration of the insulating properties of these materials. So you might want to check out which is better to protect against radiation, aluminum foil or mylar sheet, which is a better insulator, felt or construction paper or foam. Is it worth buying 3 foam sheets? Do I get a better insulator that's worth spending 3 times as much money as 1? So there's a lot of design decisions you're going to need to make. Pretty easy to test your materials. You could take your materials, so if you've got your foam sheet, let's say, you can simply put a thermometer underneath and put the heat lamp on the top and take 5 minutes, be consistent about the time, and just record how much the temperature goes up. The more the temperature goes up, the poorer the insulator. So you can do a few little quick tests just to try and get a sense as to which materials you want to use, which ones you don't want to use, which will help you be more efficient and cost effective. Which, if you're really an engineer, you're more likely to win the award for whether it's a bridge or a car or whatever, if you can come in cheaper while still accomplishing whatever the purpose is of that design. So here's the budget that you'll have. Again, you'll see the PowerPoint slides, so you'll be able to have this in front of you when you're working. I know these are not realistic for what you went out and spent on any of your materials. I'll explain to you how we got those and also why we do this. So we want to have nice round numbers for kids. So it's easy to do the math. I know a cotton ball might actually cost like, I don't know, 37 cents or something, but we don't want to make the math complicated. So these are nice, round, easy numbers for kids to be able to work with. Also adults, quite honestly, it makes it a lot easier for us to do back of the envelope math. And basically what we did is we took the unit cost, so we actually did figure out the cost of a single cotton ball, a single craft stick, etc. And then we basically normalized those, did some math to say what does that come out in nice numbers. So in other words, the aluminum foil, the like 3-inch by 3-inch square of aluminum foil and the 3-inch by 3-inch approximately square of construction paper were the cheapest for us to buy, so they're the cheapest on the budget list. So that's just a little bit of background about where those numbers came from, that we didn't just pull them out of thin air. So those are the numbers that you'll use. So you've got 2 things to think about with your materials. What are the insulating properties, and then also what's the cost. So there's always a trade-off here between cost and effectiveness. So you're going to be designing your habitat. It's a little hard to describe, but let's think about it. So your habitat has got to fit inside your solar cooker. and your penguin, your ice cube, in other words, has to fit inside. So I would say most of the habitats we get are sort of about fist size or so. Some are a little bigger. I've seen anything from like, 3 inches tall, maybe 4 inches tall. They're not going to be huge things here that you're building. You want to have the ice cube nested nicely inside. You can use as many materials as you want, as long as you stay within your budget of $400. So what I would like you to do on your first panel is to draw a picture, or just take a picture, whatever's easiest, of your first design. So once you've designed your habitat, snap a picture of it or draw a picture of it, and explain why you chose the materials you did, or why you used the design you did. So, what were your design decisions and what was your process about making those decisions. Okay. Once you've got that initial design and you've done your storyboard, then we'll be ready to test. So testing, hopefully the directions aren't too complicated. It's pretty straightforward. You're going to need to pre-weigh your ice cube. We use plastic Dixie cups because they're cheap and easy to find. It doesn't matter what you weigh it in. You can use a coffee mug, quite frankly, whatever you've got in your kitchen or your classroom. So you want to get the initial mass of your ice cube. And then you're going to want, as quickly as possible, because obviously the more you handle and have your ice cube sitting out, you're going to get some melt in. So as quickly as you can after you've recorded the initial weight, you're going to get the ice cube into your habitat. So as you do your design, you're going to want to think about having a flap or something so you can very quickly and easily get your penguin in there. And then you're going to turn the lights on your solar cooker, and you're going to put that habitat with your ice cube inside with all 3 of those heat lamps on for 20 minutes. So go make coffee, whatever, eat your dinner, eat your lunch, whatever you're up to. Come back in 20 minutes. And at 20 minutes, you can turn off the lights. You're going to take out your habitat, remove the ice cube from the habitat, and then get the final weight of your ice cube. So you'll be 2 weights, the initial, and then 20 minutes later, the post weight of your penguin. All right. Obviously, it's going to weigh less, right? So the question is, how much less does it weigh? Obviously, the closer to the initial weight, the more effective your design was. Okay. So in the second panel, I'm going to have you share your data. So tell us, how much did your habitat cost to build, and what were your pre and post weights? And then talk about how successful your design was. What seemed to work, what didn't work, what are some things you might want to change if we were to do this again. We will actually do this again in another week, but we'll do it based off of some learning. We'll be sharing our data and seeing how successful other people were with that. So what I'd like you to do, so we can sort of get a sense of sharing class data, is once you have your 2 panels ready, I will have a forum up on the Moodle site, and I'd like you just to post those 2 panels up. It'll be a forum where everyone's in the same forum, so no small groups this week. That way you can kind of look and see, wow, people did this really differently to me, or there's some similar designs. We can get a sense as to how some of those different approaches that people took to the design process, and then we'll share those and talk about those next week and how successful that they were. Okay, so that'll be on your forum post. There'll be one other thing that I'll ask you to do to share class data, and this will just make it easier for us to look across the data than opening, 20 different forum posts, etc. And so what we do when we do this in a face-to-face class is we do it up on the whiteboard, and we share. Each team comes up and they write their data onto the board. That would be awesome if I could have you all in my classroom and we could do that. So we're going to do it a slightly different way, and let's see if this will open up. It looks like it's going to work. I will have a link for this up on the Moodle site. So I'm going to have a Google spreadsheet, and so what you'll do is you go in here. I'm not sure if it'll let me type as I'm talking, but it's thinking apparently. So you'll be able to go in, you can type in your name, tell us how much your habitat cost, the initial weight of the ice cube. Try and get your weight in grams. If your balance does weigh in something different like ounces, then just annotate that so we know we're looking at something different. Final weight of your ice cube, so let's say mine weighed 8.2. I'm totally making this up as I'm talking. So the mass lost, so 10 minus 8.2, so my penguin lost 1.8 grams there in mass. And then we'll calculate the percent lost of the penguin. That's not math I can do in my head, but to figure out the percent lost, you would be doing, for my example, I lost 1.8 grams out of the initial 10. I actually could do this math in my head, but I'll put in the parentheses in because it's a spreadsheet, but you could do this on your calculator and just type it in. So 1.8 grams lost out of the initial 10 that I started with. and then times 100 to make it percent. So let's type that in. So the percent loss for my penguin was 18%, which I actually could have done in my head if I'd have thought about it. But so we'll have, so by the end of the week, all 24, I think, of you there are, will have typed your names in here, and we'll be able to, so that will give you a chance to look across the data, and we can take a look at this column and say, wow, whose was the most effective design? And then we could go back to the forum and take a look at the picture of that and start to use that information then to think about how we'd be redesigning our own habitats for next week. So, all right, that was a long explanation. I imagine there'll be questions as we go along. It's always tricky. It's always a lot easier in a classroom to come along and point and poke and show people how to work different things. So as you have questions, just keep emails coming. And I'm looking forward to seeing the creative designs that you come up with.